Let's have a look at a typical emergency power system for a home station. I've got a power strip that's representing our commercial power, and then connected onto the power strip I have a UPS. Now this is just a standard UPS that's set up. There's two sets of ports on here. The top set of ports are connected to an internal battery, and those will be used to hold the load while there's a change in AC power. The bottom ports are just surge protected ports on here. So connected onto one of the battery backup ports, I have my AC/DC power supply that's providing 12 volts to the rest of my system here. I connected to the DC power supply. Right now I have a Buddy Pole Power Plus. Now there's other devices out on the market that do a similar thing to this, such as the West Mountain Radio Epic Power Gate. And what this is going to do is it's going to take a DC power supply here into the top, and it's going to distribute that across two different circuits here. It's also got a battery connected to it. I've got a 60 amp hour Bioenno battery that's connected into the bottom. Now the Power Plus is going to act as both a battery charger, so it'll keep this battery at float. You can configure inside of the panel what's the basic chemistry of your battery. In this case, I've got it set up for lithium iron phosphate, which is what this Bioenno battery is set for. In the event of a power loss from the power supply, the Power Plus is going to switch power from that DC import automatically over to the battery port. So in which case, once we lose power down the chain, the radio should remain up and operating the entire time. So what we're going to do is we're going to simulate a full power outage from our commercial power. And I'll do that by simply turning off the power strip here. Now when I do, we should hear the UPS automatically kick in and begin alarming to let us know that we've had a power loss. Here we go. 3, 2, 1, off. And there goes the UPS alarm. We're now running off of the internal battery here, sending its power down the line. We can see that the radio is still operating at this point. Now, the next thing that would likely fail is that this internal battery, we only have maybe about 15 or 20 minutes worth of runtime off of the internal battery, depending on the amount of equipment that you have plugged in here. And we'll want to make sure that we can get any additional changeover of power source possible in that amount of time. But in the meantime, let's go ahead and simulate what would happen if this device were to fully lose power. So at this point, you can see that the light is on here on the Power Plus. So I'm going to go ahead and turn off the UPS at this point. And as I do, you can see that our power supply here just powers down. And we can see that the light has changed here on the Power Plus. It's gone to an amber color, and we're still operating the radio. We've not lost power to our radio at all at this point. So everything is still operational. And to continue this simulation, I'm going to go ahead and I'm going to unplug the UPS so we can see that we're completely off of power. I'm going to start up the generator. We'll get that started, and then we'll repower the entire system. So my generator is set up here. This is it's a Honda EU 2200i, and it's a really good generator. It's pretty simple to be able to operate. I'll flip the choke on real quick, turn it to the on position. I've already got the gas set so that vapor lock is opened up, so the gas should flow. So let me give it a pull start. Starts up on pretty much one pull. I'll flip the choke back. Once it's up and running, everything's running smoothly. Now the generator is running in eco mode, so it's running in a much more reduced fuel consumption mode, and that's really good to be able to help conserve our fuel while we're operating. Now with that all set up, I'll go ahead and turn the UPS back on, and then we'll get our power supply. Will automatically come back up. Now I should be able to just simply plug in the UPS. Now, once again, we're running off of the AC source that's coming. This time it's coming from our generator, and it's keeping our entire signal chain up and running. So this is a basic setup for having redundant emergency power all the time online in a home station. You likely wouldn't take this full setup out in the field unless you're deployed to an emergency operations center or an incident command center or some other location where you have access to a larger generator, or maybe you're bringing your main generator to power a trailer for your communications unit or what have you. But having a setup like this where you can go to a UPS that has internal battery power and then having an external battery that's going to handle the load once this changes over. The other thing that this is going to do is protect you against brownouts. So if you're operating in a location where you're running off of a generator primarily, and the generator runs out of fuel, they've got to refuel the generator, maybe switch to a second one. Having a UPS with you that's in line to protect the rest of your gear is a really good idea to have in your kit. It doesn't have to be a very large one, just large enough to be able to hold over the equipment that you're planning to be able to operate. Hey, thanks a lot for joining us today on WaveTalkers Live. Obviously, we're talking about emergency power, and we're talking about PACE plans a little bit. Now, the PACE plan that we just laid out here, now this could be typical for a home station, maybe for a Winlink RMS gateway, or some other similar kind of situation that you would have. And we walked through just a high level of a PACE plan here, which would be your primary source of power, which would be commercial power. The alternate, in this case, we're using a UPS or an uninterruptible power supply in order to create that quick changeover to make sure that your devices are all staying powered up, ready to run. Our contingency in this case was a battery backup that we had that was connected through that Power Plus, and it was providing that additional power to keep our radio or whatever equipment up and operating throughout the time that we were working. And then we had our emergency power, which we were able to use a generator to be able to dump some power back into the entire system, keep things up and operating as long as possible. So this is kind of a high level as to what an overall PACE plan may be for, say, a home station. Now, when I'm out sailing out on the boat, my emergency PACE plan on the boat is going to be a little bit different. Primary is going to be either commercial or shore power. Now, that's if I'm still at the dock. Once I head out to sea, then I immediately go into my next stage of my PACE plan where my alternate power kicks in. That's my house battery. And I've got two banks of batteries in the sailboat. I've got the primary house battery bank, a secondary house battery bank. Now, that second bank is actually used to run all my communication systems on, so I can keep those two systems even separate. But at any point, I could combine those as need be. My contingency when I'm out at sea would actually be to start the generator or start the engine and use the alternator to throw power back into the battery, run the charger and so forth, or have an external generator plug that in. That emergency power is oftentimes going to fall down into that internal batteries into devices or primary batteries, AA's, AAA's, whatever those happen to be. So you can start to see that as you start really thinking about what your power needs are to keep your equipment up and running, you're going to get into a situation where you're going to come up with a blend of different tools that you can use to keep all of your devices powered up. And the best way to really kind of think about this is to really come up with an overall blend of all of the power needs that you have. And I like to think of using my batteries as my working power. So in essentially whenever I'm operating my radios here at home or I'm working on or I'm out in the field, I'll oftentimes have the batteries providing the bulk of the power source. And then what I'm using commercial power, my renewable power, or fossil fuel generators for is to constantly keep these batteries running at float, constantly topped up so that they're always ready to continue to take over the load in case of any particular failure. And by diversifying out your power generation and having enough battery capacity to be able to carry you through any emergency, it really gives you a lot of flexibility in order to carry yourself through any sort of emergency. So that brings us to our check-in, and where we would like everybody, if you have access to Winlink, then please open up Winlink. Send us in a Winlink check-in. You can send it to all four of our call signs. Those are W0DHG, NR6V, KM6RFB, W6AH, and our tactical address, WaveTalkers. Now, use the standard Winlink check-in form. We'll walk through this process here in just a second. And in the comment section of that check-in form, let us know what your emergency power PACE plan is. Now, let me jump over quickly here to my laptop, and I've got my Windows set up here. I've got my Winlink copy up and running. Let's go ahead and step through that process of doing a check-in. So I'm going to come up here to the top of the toolbar. I'm going to hit the little open up a new message, and I'm going to go up here to the select template option. That's going to bring up my template manager. You want to click the plus next to the standard templates, and you're going to come down here and find that general forms. Click on that, and down near the bottom, you should find Winlink check-in.txt. Go ahead and give that a double click, and it should open up your web browser of choice. Now you're going to come up here in the date and time field, give that a click. It's going to set the current date and time for your computer for this particular form. Go ahead and hit OK. Here's the to field. This is where you want to enter in all of our call signs. We'll enter that into the chat on the various different platforms, so it's easier for you to be able to just copy and paste that in. In the from field, this is where you're going to list your call sign. Station contact information is going to be your name. Initial operators is going to be any other operators that are sitting watching with you, either live in our Zoom audience or watching us on our YouTube live stream. And if you're watching us on YouTube, thanks a lot for joining us there. We're also broadcasting as well on LinkedIn Live and Facebook Live as well. So thanks a lot for all of you joining. This is a great time if you're going to like the content that we're going to do. Go ahead and like that video and leave us a comment in the YouTube as well about what your PACE plan is. Here's that session type. This is going to be an exercise. Let us know the service that you're sending this in on, either amateur radio or shares. For the band, let us know if you're using Telnet, which would be the internet, or any of the other major bands here for the amateur side. In the session type, you can tell us how you're sending that in. Telnet for internet, again, packet, PACTOR, VARA, so forth. Here's the location information. You're going to want to let us know where you're sending that in from. I'm going to list out my home QTH. Your latitude and longitude should automatically be filled in for you based on the center of your grid square, or if you have a GPS connected. Down here is that comment section. This is where you want to let us know what your PACE plan is for emergency power. I'm just going ahead and enter in PACE. When you're finished, you hit the submit button, and you'll get a couple of these little pop-up windows that'll just come up. You just keep clicking OK until your browser window closes, and then you should find all that information listed out here. You can go ahead and post that to your outbox. And when you do, you should see one item in your outbox. You can then open up the session and go ahead and send in that traffic. At the end of the show, we'll check back in and we'll map in all of these check-ins. It looks like we've got check-ins coming in from around the world. I'll go ahead and download those at this point. We'll keep checking as time goes on. But for right now, let's get back into today's topic. Where's my mouse? There we are. All right, so when you start thinking about your overall PACE plan, what you want to do is you want to design your emergency power plan for your expected needs. And then once you have that PACE plan, once you have the way that you're going to provide emergency power for your own needs, you want to be able to adapt to whatever your current situation is. We can all plan all day long for whatever event is going to come our way, but when you actually get in the situation, all the situations are going to be slightly different. So being familiar with your gear that you've got, all the different components of your PACE plan, is really going to help you as you need to move forward and adapt to whatever the changing circumstances are going to be. Now, the first question you always need to ask yourself is, what do you need to power, and how long do you need to sustain operation of those various different devices? And this is going to be different for every single person. And the things that usually come to mind right away, and the first is any information devices. This is oftentimes our cell phones, our mobile devices, laptops, other things that back in the long, long ago when we used to keep all this stuff in our heads, or we would have notes down on everything. Now we keep all of that in our mobile devices, our laptops. And so being able to access that information is oftentimes really helpful to be able to have. Now, this is not the only thing that you want to make sure that you've got. The of primary concern is making sure you have your health and safety needs taken care of. So let's say you're somebody who needs a medical device such as a CPAP to be able to sleep at night. Making sure you've got enough emergency power to be able to sleep comfortably is really critical. Or any other different medical devices that you need to have. This could also fall into the category of making sure that you have some way to power critical devices in your home, such as your refrigerator or your freezer, to make sure that your food stays safe. If you live in an area where you have your water source comes from a local well on your property, like I used to have when I lived back east, you need to make sure you have a way to be able to power that well pump so that you're able to have fresh water to be able to drink. So there's lots of different components in this health and safety area to really consider. Now, for many of us ham radio operators or emergency communicators, having communication devices that are powered is really critical, so you can get the word out to to let people know what your situation is, whether or not you're safe, or whether or not to be able to provide aid to others as well. Communication devices are really absolutely critical. And then we'll throw in this other category for any other devices that are going to fall into your specific needs for power. And these could be devices that need AC power or devices that can be powered off of USB. A lot of devices these days can be powered off of USB, both A and C, in order to keep a lot of these different devices up and running. So that's been a real boost to all of our emergency communication plans and our PACE plans by having a lot of devices that we can use that common power for. So let's walk through some of the different components that we need to think about when it comes to emergency power. And the first is power storage, because when you're just doing your day-to-day operating, you will oftentimes get in a situation where you're just pulling power directly from the grid to power all of your devices. But when the grid goes away, you need a way to continue to provide power to your devices. And that's usually going to come in the form of power storage. So let's have a look at that first. Let's have a look at some of the different battery options that you're going to have available to you when you start thinking about emergency power. And I've got an array of them set out here for you to be able to see. And they're broken into a couple of different categories. The first are your lead acid batteries, also called SLA for sealed lead acid. This one here is a motorcycle battery. This one comes out of a UPS power supply. These are relatively inexpensive batteries that you're able to pick up and use as a larger storage device for charging various different devices from, or even running equipment directly off of the battery, provided it can run off of 12 volts. Now, the disadvantage to these is that they're very heavy. Also, some of them, like the motorcycle battery here, you need to fill the various different chambers or cells with a acid solution. You have little caps that goes on it, so you need to be careful about whether or not they get tipped over. There are batteries such as this one that are completely sealed, that do not have any kind of problem with orientation to them. But one of the biggest disadvantages, aside from the overall weight to your lead acid batteries, is when you pull current out of the battery and you're using it to power various different devices, these tend to only have about a 50% delivery of power for what they're able to deliver to your device, because the voltages drop off very precipitously after a particular level of power has been pulled out of the batteries. That means that even though you may see a battery that says this is an 8 amp hour or a 50 amp hour or a 100 amp hour battery, you're not going to get that much power out at the voltage you need in order to run some electronics such as radio equipment. A better option for running your emergency communications equipment is something like a lithium iron phosphate battery. Now, these are batteries that are by Bioenno. There are other manufacturers out there that make them. They come in various different sizes and shapes depending on what the specific needs that you have. So, for instance, and when I'm out operating QRP, I'll carry one of my smaller batteries, such as this 3 amp hour battery, or maybe if I'm going to be on a little bit longer trip, I might take the 12 amp hour lithium iron phosphate battery. If I'm operating some gear that's a little bit higher power, maybe I need to operate a 100-watt radio, or I need to operate a 50-watt mobile VHF, UHF radio, then I'll go with something like a 30 amp hour battery, or maybe my 60 or 80 amp hour battery. Now, each of these different batteries has different connectors on them for being able to plug in your gear and get it to drive that. This third category of batteries that I've got it thrown in here as just other is a mix between the primary batteries that we have on our HTs. All of our handheld radios come with some kind of a small battery that clips onto the back. These come in various different sizes that you're able to power your gear. It's a really good idea to have at least one spare for your radio. A better idea is to not only have a spare primary battery that's rechargeable, but also pick up a clamshell. Now, the clamshells, this is a case for a battery for a particular type of radio, and you can find these for most any of the various different radios that we use, but these will take primary cells, so AA or AAA usually. You'll find these on deployments quite often because it's very easy to simply swap out the batteries and get an operator back in the field continuing to operate than it is to take all of the batteries, plug them into a charger, put them in a bank of chargers, and charge them all up. That's still done as well, but we do see this quite often, and these are available for pretty much all of the radios that we have available to us. Now, a matching battery like this is still going to flip down into a charger, so you're able to keep that charged. Some other options for batteries that are going to be pretty familiar to you are going to be things like USB power banks. These are great because they've got an array of batteries inside. These are great for charging your mobile devices, your tablets. You can even run some radios off of these, such as the ICOM 705. You can plug that in to here and be able to make that powered. There's usually a little battery indicator that you can click so you can see how much power is left inside the bank. These are things that we should have in our kits all the time. Now, the last category are some of these alternative batteries that you may have around, such as camera or film batteries that you can get. Oftentimes you can get adapters for these so that you can get out to, say, a power pole connection, a 12-volt socket plug connection, or something like that, so you can power other devices off of these. Now, this battery here, this is used in the film industry quite a bit. These come in two varieties. There's gold back and there's also V batteries. And these also put out 12 volts of power, and they use this D-tap system. And you can find D-taps available to, again, adapt your equipment so that you can use these as well. These are nice and compact. You can usually find these used for film sets and other film gear around. So that's a quick look at some of the different battery technologies that you're going to want to have. You always want to make sure that when you're choosing a way to charge your battery, you're using an appropriate charger for the chemistry and for the type of battery that you're going to be charging and using. Now, I am seeing quite a few comments in the chat, both here inside of our live Zoom audience as well as out on YouTube, of folks that are talking about their electric vehicles that have a large capacity of power that they can use in the event of an emergency. I've seen notes on here about Teslas and Priuses and the Ford F-150 Lightning and so forth. All of those are great choices for being able to have that additional storage of power. We also didn't talk about things like your power walls that you may have at your house, or things that you can help to support overall in your home. So we're mostly thinking of the kind of the portable setups that we've got here. But let's move on now a little bit and talk about power generation. And we start talking about power generation, we're really typically looking at two primary methods, either fossil fuel generators
or solar. So let's start off, talk a little bit about some fossil fuel generators. Now, this is the one that I have. It's a Honda 2200, and it's a great generator. It's really small. It works really well. It's got a Bluetooth connection inside of the generator, so it connects to an app on my phone. So it tells me all about the maintenance that I need to do for the generator. It lets me know when it's time to change the oil and so forth. It lets me know the number of hours that it's been running and so forth. Starting these is really pretty easy. You saw me do it in that first video. Essentially, you need to be able to flip the choke on if it's cold. You open up in the top where the gas cap is. There's a little air vent. You can turn that to on, and that allows the fuel to be able to flow through the entire system. You turn that little switch down at the bottom into the on position, and you give it a pull. As long as you periodically start your generator, generally these Hondas work really, really well. I've been very pleased with it. Now, I have let mine sit for a couple of months and haven't used it. And if you don't, when you go to shut it off, if you don't close off the top air valve first and then let the thing just kind of run out of the fuel that's inside of the bulb, it can gum up the carburetor a little bit, and you might need to do some cleaning, get some carburetor cleaner to get in there and spray in there to get it to pull start at a later time. But generally, it's not too bad. Now, when it comes to safety for your generators, you want to make sure that you never, ever run these inside. Always make sure that they're outside, and make sure that exhaust is pointed away from any open windows or doors. Or if you're with an emergency operations group, and you're operating out of, say, a trailer or a portable command center, you want to make sure that that exhaust is not pointed into the trailer. I've been on situations, I've been on events where somebody would start up a generator, and because the wind was blowing in the direction of the back open door of a trailer that we were in, that the diesel fuel or the exhaust smell would come directly in, and that can really adversely affect both your health and especially anyone who has any compromised breathing systems such as asthma or so forth. So you want to make sure that your exhaust is pointed downwind from wherever you're going to be set up and operating. And one of the biggest challenges, and we saw this with the Hurricane Helene response, with using fossil fuel generators like this, is oftentimes in a situation where there's a major disaster, fuel can be difficult to be able to come by. And so you want to be as conservative as you can with using these when you absolutely need to, and conserve amount of time that you're able to use them. And that leads us to a better renewable source that you can add into the blend of your power plan, and that is to use some solar mixed into your overall plan. Now, there's three major types of solar panels that are out on the market today. There's the monocrystalline panels, the polycrystalline panels, and the thin film panels. And we'll talk about each of those in this next segment.
Now let's have a look at some various different solar panels that are available. And solar panels generally come in three basic types. The first type are generally the cheapest that you're going to find. These are called polycrystalline panels. And you can see as you look at these, they're generally blue in color. And if you look closely, there's little flecks that you can see in the panel itself. These are created by having multiple small crystals that are sandwiched together in order to create one single panel. These are a lot less efficient than some of the other different types that we have here. These are generally the ones that you're going to find at low-cost panels, although this one is a little bit older technology. It's not very efficient anymore. This is about a 28-watt panel. I'm going to go ahead and move that off to the side. In general, you should try and avoid the polycrystalline panels if you can. They're just not very efficient. They tend to be larger and quite a bit bulkier. The next type are the monocrystalline panels, and I've got 3 different examples of those. This set here, these are 28 watt panels, and these are foldable. You can see that they kind of fold out. They've got 4 different segments that are on them. These are a lot more efficient, and you can have multiples of these, and you can link them together using the wiring kit that comes in the kit as well. These are all by Bioenno Power. They're pretty nice because they're pretty compact, and you're able to charge small devices off of these in order to keep yourself up and running. I've also got a little bit larger one. This is a 60 amp hour panel. Same basic idea. I've got another one down here so I can open it up and show you. When they come, they come in a nice kind of case similar to this. On the back side of the case, there's a pocket, and this is a good place to be able to keep some of the wiring that you may need. So I keep a long length of wire that's rigged up for connecting to power poles into all of my solar charge controllers. Go ahead and zip that back up. And then inside of the panel itself, this has a Velcro closure. You're able to simply open up the panel, and on the back side of the panel are these 2 legs, and if I flip this up the correct orientation, these are used, there's 2 of them on here, to be able to set the panel up like you see it, to be able to get the most appropriate level of sun. These also have grommets in them, so if you needed to hang the panel from a location, you're able to do that as well, to passively collect as much solar radiation as you can. The other type of monocrystalline panel that I have is this one here. This is a rigid panel. It's quite efficient. This is also a 60 watt panel. This one here is much more efficient than the more foldable panels, although it comes at the cost of a little bit extra weight and a little more difficult to be able to pack and move around. This does come with a padded case, so it's easier to be able to transport. But if you're looking for something more transportable, either go with these foldable panels or consider the third type, which are these flexible panels. They're also called foldable, but these are a lot more foldable. These are by PowerFilm Solar. This is also a 60 watt panel. If you haven't guessed, the 60 watt panel is the size that I use most often for most of my equipment. It keeps most of my equipment up and running throughout the day, unless I'm doing some really high powered, constantly running at 100 watts or so forth. A single 60 watt panel is generally good enough to get the job done. Now with these foldable panels by PowerFilm Solar, you can see you can open these up, and then they simply just fold out. And you're able to take these, throw them out on the ground. It's got grommets in the corners, so you could hang it from a location if you needed to, drape it over the front of a vehicle to maintain power. Now, one of the big differences between the various different panels is the overall efficiency. So you can see this 60 watt panel is quite a bit larger than some of these other 60 watt panels. These are not quite as efficient at collecting the sun, so you need a little bit more surface area of solar panels of the solar cells in order to create the same amount of power. However, the big advantage to the way that these PowerFilm solar panels are created is that these are wired entirely differently so that they're much more shade tolerant. So in the shade, these panels, even if a little segment is shaded or if you have part of it closed off, these panels are going to continue to create the same amount of power per individual grid, whereas these other monocrystalline panels, you can see in the back where we've got that partial shading that's on this panel, that panel is not going to be producing anywhere near enough electricity in order to keep your gear up and running. You want to make sure that you got full sun, full coverage on your monocrystalline panels as much as you can. Now, the other panels that I have here, these are 120 watt panels. These are also by Power Film Solar. These are just quite a bit larger, and you can get various different wiring kits, either pre-made, or I've made some of my own to be able to wire up multiple panels together, either in parallel or in series, depending on the specific needs or the solar charge controller that I'm operating, to know what the power requirements are, or what the power can, or what that particular solar charge controller is able to handle. By changing the wiring of your panels, that'll also indicate the size of the wires that you need in order to reduce the amount of losses that you have to spread out your solar panels. Solar is great because you're able to passively collect power throughout the day, and ideally you want to get your panels up and running early in the morning and make sure that they're charging your batteries throughout the day, so when it comes to the evening time, you've got enough power stored in your batteries to get you through the night, and then enough to get you through the morning as the sun starts coming up, to carry you through that overtime when the panels are not quite producing as much power as the sun's rising as you're needing to operate your gear. So you always want to oversize your batteries when you're working with solar, if you possibly can, in order to get you through those continuous operation times. One of the great things about using solar panels in order to power your equipment, though, is that the sun is always shining during the day, so you're not going to run into a situation where fossil fuels become quite difficult to be able to obtain, and you're not able to continue to power your gear. Having a solar backup is going to ensure that you're able to continue to power your equipment as you need. Now, what's the best solution? Probably a hybrid solution that's going to have some combination of generators, solar panels, and if you have the ability to capture other types of power, such as portable wind generation, to put all of those in the mix to have a complete solution, so that you have as many options as you need to be able to get the job done.
So in that segment, one of the things that I talked about quite a bit was the shade tolerance. And shade tolerance is actually a really big issue. One of the times when I spent about a month cruising in a small sailboat, and we operated, all of our power came from solar panels that we had on the boat. One of the things that became a real issue was that partial shading of the panels. So, for instance, when a single line or a rope would lay over top of one of the panels, it was amazing to see the impact that that little tiny shading over a panel would do to the overall collective output of those panels. And most of your monocrystalline, and especially the polycrystalline panels, are wired in a way that they're optimized to be able to give you the right amount of voltage and a decent amount of current that comes out of them, but they're not wired generally for shade tolerance. And so it is definitely something, as in emergency communications, that you need to be paying attention to. As a matter of fact, at Baker to Vegas a couple of years ago, we set out and I deployed a solar system to be able to keep one of the medic radios up and operating throughout the day, and it worked great until the sun started to go behind one of the panels, and as soon as we started getting a little partial shading, the output of the panels dropped precipitously, and so we had to keep making sure we were moving the panels and monitoring and optimizing for placement for the sun to be able to get as much power out of them as possible. So it is definitely something to be aware of. Those Power Film solar panels are absolutely incredible in their shade tolerance that they have for continuing to output. Now, you do pay a price for that, and that comes in the cost, but the flexibility of those panels, those are definitely the 60 amp hour or the 60 watt panels are definitely my go-to. They're the ones that I carry with me all the time in all of my Go kits that I have. So the challenge with one of the challenges with solar is you can't just plug your solar panels directly into your battery. That is a really bad idea. What you need to do is you need to make sure you have a solar charge controller in the mix. And what the solar charge controller is doing is it's taking the power that's being generated by your solar panels and it's regulating for the power that goes then into the battery for being able to charge the battery based on the chemistry of the battery that you're using. lead acid, lithium iron phosphate, maybe you've got one of the other different battery technologies, and your solar charge controller is going to be delivering the power to the battery to charge all the cells evenly and at the appropriate rates. Many of the solar charge controllers will also have power output ports to be able to power additional devices such as your radio or other equipment. You may need other devices like we will see in a little while in one of the later episodes here, but this is kind of the overall system. So let's look at some solar charge controllers in a bit more detail now.
Now let's look at some solar charge controllers, and there's a lot of them out there on the market, but this is just a small collection of some of the ones that you're likely to encounter. So let's have a look at them. Anytime you want to charge your batteries off of a solar panel, you want to make sure that you're using a solar charge controller. Never connect a solar panel directly to a battery system without a solar charge controller in the mix. Now, these are broken into two main categories: PWM, or pulse width modulated chargers, and the MPPT, or maximum power point transfer. These basically have computers inside that are regulating the power and the voltage that's going out to match exactly the chemistry of the battery that you're going to be charging. Now, a PWM is a pulse width modulated charge controller, and what these are going to do is send out a regulated amount of current and voltage that's appropriate to the battery technology that you set. And with all of these, there's switches inside that you can go in either through the front panel or through internal dip switches that you can go in and set the appropriate chemistry that you're going to be charging for your battery. Now, the other thing to know about solar charge controllers is that they will handle different amounts of current. So, for instance, these two, the Buddy Pole Power Mini and the Jenison, are limited to 10.5 amps of power that you're going to bring in, whereas some of these other ones, such as this one, can handle 20 amps of power, when this one here can handle 30 amps of power, both in and out. Now, that can make a difference depending on the number of solar panels and how you have them connected, either in parallel or in series, because that'll vary the voltage as well as the current that's going into them, and then what your overall load of your devices is going to be. You need to match all of this together to make sure it all works. In an emergency situation, you may not have to worry so much about optimizing every single volt that you're getting by using an MPPT. These are more efficient to be able to manage the power that you're getting in from your solar panels, charging your battery, and out to your load. In a long-term situation, these will make a big difference. In a short-term situation, though, really any of these are going to operate really well for you. Now, off of pretty much all of your solar charge controllers, you're either going to have 2 leads to them, or you're going to have 3 leads. And all of these all have 3 leads except for this one. This one only has 2. Now, the Jenison is set up, and I make sure that I always label them, even though they're labeled on each of the different devices what the ports are. But I try and come up with a color coding so I always know what is the appropriate thing to be able to plug in. So for instance, I always use yellow in order to indicate my solar panels because the sun is yellow, and I use green to indicate the battery, and then I'll use a blue to indicate the load port on it. So the Jenison only has a place to be able to hook up the battery and the solar panel, so it's just going to charge. It's not going to then distribute the power. That's going to come directly off of the second lead on your battery that you've got here. So you want to make sure that your connectors are all matched for the way that you're going to plug in and charge your battery. You want to make sure that the wires are appropriately sized for the amount of current that you're planning on using. And then everything is clearly labeled, so it's very easy to have somebody connect up and not plug in a battery into the wrong port or plug in a load into the wrong port on the devices. Now, these two here also have USB ports on them, and the USB ports can be used to charge additional devices that will use USB power. The last thing that you want to keep in mind is whether or not your solar charge controllers are RF quiet. So some of these, such as these three, are really pretty good for being RF quiet, meaning you can plug them into the system and you don't have to mitigate a lot of the noise that's going to be coming out of many solar charge controllers. If you go online and you get some of the really low cost ones, then oftentimes when you plug that into your radio system, you'll start seeing your noise floor rise up. This one here, which can handle a good amount of current, is great, except for this was designed not for the radio market, and so it has quite a bit more noise that's going to be generated. It's not a problem, you can mitigate that, but it's just something to be aware of when you set up to go in the field. Obviously, the Power Mini is really set up for portable use. It's really set up for operators to use. It's got power poles on the outside for the inputs and the outputs, making it very easy to adapt all of your gear. All of the rest of these you need to hook up your own leads to in order to make them work. The last thing to keep in mind is if you're charging various different types of battery chemistries, you may need to be able to have a solar charge controller that will monitor the temperature of the battery. And many of these charge controllers will come with a temperature probe. For instance, this one goes to this one here, and you can set this so that it's attached onto the battery. It's got ports to plug into here, and if you're using, say, a lead acid battery or an SLA battery, then you're able to hook this up and monitor the temperature of the battery and match that with the charging rate for the device.
So once you get your power generated and you're storing your power, now you need a way to distribute that power out to your various devices, as well as being able to share that power with other users. Let's have a look at some of the ways that you might be able to do that.
The next topic with emergency power is how are you going to capture the power that's available to you, and then how are you going to utilize that power, both distributing it to your own equipment as well as sharing it with other users or other operators that are at the location where you're currently located. And these fall into a bunch of different categories. I just have a variety of examples here to get you thinking about the things that you may want to include in your own kit. So over here on this side, I have some power inverters. Now what these are going to do is they're going to take a DC source, such as a car battery or any of the other 12-volt batteries that you have. You can bring that power in and then convert it into AC to run a variety of different devices. Now, if you're going to be running radio equipment, generally going all the way to AC and then converting it back to DC for your radio equipment is not a good idea. Just get down to the DC power sources and adapt those into your radio. If you need to do this, though, make sure that you have a pure sine wave power inverter to get the cleanest power into your overall radio system. Another thing to keep in mind is what are you going to be pulling power from? So for instance, many generators will have a 30 amp plug on them, or maybe you're trying to adapt to an RV power system that you're going to tap into. So having a variety of different adapters that will work with the equipment that you have can really make a difference for being able to make sure that you get the power that you need where you need to be able to get it to. Then you need to distribute that power. So one thing that I always keep in my kit is a power strip. It's got a surge protector on it. These are not very expensive. They're pretty easy to be able to come by. They've got places to be able to plug in a variety of different AC outlets to it. However, once you get a variety of outlets here, you're always going to have more people who are going to want to tap in and utilize some of that power, or maybe you need to plug in a variety of different devices that are going to have DC, that are going to have wall warts that would take up some of the ports. So a couple of options to keep in your kit, one of which is get yourself a bunch of these really short extension cords, because what's nice about these is you can plug them into a power strip and then you can distribute out the additional ports from there to be able to plug in wall warts, and then you can utilize all of the ports that are in here. Generally, when you're running low power devices, none of them use very much power, so you're able to connect more devices into your overall load. Another option is to use what's called a cube tap. Now these just plug into a single outlet, and then they've got outlets on 3 different sides. Oftentimes you can plug various different wall warts into that to distribute the power out. Another really nice thing is you can find, these are some of the Apple USB power adapters, and these have, you can find the adapters for those with a longer tail on them, and you can adapt these to various different power systems for around the world. They simply have a different duck head that clicks in, or you can use these longer tails. Now you can get the power for your USB power where you need it. Speaking of USB power, another thing that you may want to consider getting is a multi-port charger. Now these will just plug into a regular AC port and then it'll give you multiple USB. Now you can get these in USB-A or USB-C ports to distribute power to a variety of different devices. It's always nice when you go up to somebody who already has access to a power port, if you can redistribute that power back out so that you can share off of it, or you can provide charging for their devices. They're much more likely to be able to give you access to one of the ports if you're able to share that out with other people. When it comes to your radio equipment, it's a good idea to have equipment that you can tap into existing sources of power. So for instance, I always have a set of large alligator clips that I can attach onto a battery with that and get my 12 volt and get my power poles connection off of it. I always keep fuses in line to protect all of the equipment. With something like this in your kit, you're able to then leverage any found batteries that you could use in order to provide additional power that's going in. Another thing that I keep in my kit are a variety of these 12-volt socket connectors. Now, what's nice about these is you're able to plug into a 12-volt socket connector inside a vehicle and then distribute that out. You can get ones that just have a pair of ports on it, one single port. These are great because you can buy these fairly cheaply. This one here, I went ahead and just bought a pair of them off of Amazon. I cut the leads off of it and soldered on my own adapters to be able to get to a power pole connector, and you can do this with both the plug and the socket to get yourself a lot of flexibility in what you need to use. Once you get your power in, you're going to want to be able to distribute that power out. So this is a rig runner by West Mountain Radio, and each of these different ports are fused, and they just use standard automotive fuses. You can usually bring in your main power into the top end and then distribute that out to a variety of different ones that you have the appropriate size fuse for the equipment that you're going to be plugging into. The last thing that I have with me here is I usually have a lot of these different adapters. I keep them in just a plastic box, and I've got a variety of adapters that I use for multiple different situations, and I can keep those all in one spot to make sure that it's easy to be able to access and find the adapter that I need to deal with the situation that I have at hand.
So when you pull all of these different components together, you have a very robust overall solar powered system that is quite flexible for being able to keep your batteries charged and keep all of your equipment operating and running. So in this next segment, I want to walk through what that complete system may look like. And there's a lot of variation that you can obviously sub in various different equipment for, but this should give you a pretty good idea of how all of these different components all feed together to operate as a single whole.
Let's have a look at a fairly complete off-grid power system. Now, this system that I've got set up is being charged by solar panels that are over here behind me, and we're using two separate batteries as our primary battery and our backup battery. The signal chain that we have here, the first device is your solar charge controller. The solar charge controllers are set up so that you always want to provide power to the solar charge controller by connecting it to the battery first. That boots up the electronics that are inside, and it makes it ready to be able to operate. Once your solar charge controller has been booted, you can then plug in your solar panels. Now, after you plug in the solar panels, that's when you would want to go ahead and open the solar panels up so that they're collecting sunlight and generating power. It's never a good idea to just have a solar panel sitting out in the sun generating power with no load attached to it. Now, you never want to connect your solar panels directly to any battery system because you're going to have variations in the amount of solar radiation that's hitting the solar panels, thus the amount of charge and power that's going through the panels and into your battery system. Bad things could happen. So instead, you always want to make sure you have a solar charge controller that's managing the process for you. Another thing that solar charge controllers do is they have blocking diodes inside of them so that if in the event that we go into shadow, we lose the sun maybe at the end of the day, your battery is not pumping the energy that you had just collected into it back into the solar panels and radiating those back out as heat. So you always want to have a solar charge controller whenever you're running solar. Not all solar charge controllers are created equal. Now, out of the Buddy Pole Power Mini, what we've got is we've got the output from one of the load ports going into our DC in port on our Buddy Pole Power Plus. Now, this is acting as an uninterruptible power supply for us. Now, the first battery is providing the initial charge that's driving all of our equipment. The second battery is acting as a backup battery for us. So in the event that the primary battery gets fully depleted, it goes offline, and we can represent that by simply unplugging this. We can see that the Buddy Pole Power Plus stays up and keeps our equipment up and operating because it's pulling now its load directly off of this second battery. The Power Plus also has some power distribution that's set up here. There's two circuits. You can use the on-screen controls in order to balance out how much current is flowing to each of the two different sides. We're not going to go into that right now, but you can see very quickly how this whole system just comes together. I'll go ahead and plug this back in. Now we have our whole system up and running, ready to go.
Hey, this is a great time to give a big thanks out to the three folks who really helped us make this episode possible. Bioenno Power, Power Film Solar, and Buddy Pole, who did provide a lot of the equipment that we were able to use to create this. So a big thanks and a big shout out to all of those folks for all of that equipment. Before we dive into checking out the map and seeing where all the check-ins have come from, this would be a great time if you're watching us on YouTube or any of the other channels to like the video and leave us a comment. Tell us what you think and tell us a little bit about what your insights were from watching today's episode. With that, let's jump over to the laptop again. Now, I've been downloading some of our check-ins as we've been going along, but I'll do another quick check to make sure that we've gotten all of the check-ins and make sure that they've all come in at this point. It looks like I've gotten quite a few of them at this point, so I'll go ahead and close that. Now, let's map all of these, and I'm going to do that by coming up here in the menu bar, and I'm going to click the little globe icon. That's going to bring up the maps and CSV KML file. You can see the drop down here is going to let us select the appropriate form that we want to check. Now, if you want to map these out yourself for your own check-in, for your own messages, then go ahead and select messages, and you can see a map of where all of the Winlink messages have come into your account. But you have to receive the form in order to map the actual form. So I've gotten those. I'm going to come down here to Winlink check-in.v5. I'm going to go ahead and select that and hit the display map icon. That's going to bring up a map, and I'm going to go ahead and blow that out to full screen here. And let me go ahead and zoom all the way out so we can get an overall view of planet Earth, and we can see the check-ins that are coming in from around the globe. Now, you can see the various different colored pins that we have. Now, this is one of the nice features about Winlink. I'm going to come up here to the set filters option, and we can see that operators who sent in their check-in via Telnet or use the internet, those are going to be the purple pins, and all of the other pins are going to be ones that sent in their messages via RF, either VHF, UHF, or HF. So we'll just do a quick run around and see who has sent in their check-ins. Here in Sydney, we got Victor Kilo 2, Sierra Kilo Yankee joining us. We also have Sierra Mike 7, Yankee Tango November, and this should be Roland. Oh, no, this is Franz, Oscar Echo 3, Foxtrot Quebec uniform, joining us from Austria. Hey, thanks a lot for joining us there. Let me go ahead and zoom in on North America a couple of times. I'm going to right-click and drag in order to pan the map over, and we'll roll over these different check-ins so that folks can see that we did receive their check-in. They showed up on the map in the location where they were from. We've got a couple of them right here. Yeah, there's Ed's. We'll jump down here a little further. We'll come over here into the Carolinas. Just absolutely incredible work that's going on with operators helping all in this southeast region, from Hurricane Milton, Hurricane Helene, with the response effort that's going on in there. Quite a bit of Winlink traffic has been being passed to support all of those folks. And it does seem like that much of the communications has at least stabilized in many areas. It may not be everywhere yet, but it looks like it is starting to stabilize with some of the recoveries, which is why we're doing the check-ins again at this point. Let me go ahead and zoom in a little bit on the Pacific Northwest, because we do have quite a few operators that are up here in this area. And with the map pulled back a little bit further, it's a little hard to make sure we can see them all. We'll just go ahead and roll over each of these, make sure folks are able to see that we did get their check-ins. All right, let me come on down to the south a little bit, make sure we see our friend here in Medford. There we go. Let's come on down a little bit further, and we've got some more folks that are all up in this area, up in the Piedmont area of... Oh, there's California. Oh, look, we've got the State Operations Center. Looks like they're sending in a check-in to us today. Thanks a lot for that. Appreciate that, coming in from California. And operators that are coming in from all over. Let me go ahead and zoom in a little tighter on Southern California, our home area here, where we've got a few more operators that are sending in their traffic as well. Appreciate to see everybody sending in their Winlink check-ins to us at this time. So really appreciate that. Again, if you found any of this information helpful, be sure to like the video and subscribe if you're not already subscribed to us. Let me go ahead and jump back up into my studio, and we'll bring the guys up. I know David's out on assignment this week, but we do have Dan and Scott are joining us as well. Dan, let's start off with you. What kind of thoughts do you have from today, and what kind of things did I miss?
Well, there was one request in the chat about talk about inverters, which we can probably do in the postnet. I thought you did a great overview. Obviously, you could deep dive into any of these topics and get really down in the weeds about it, but it gives you an idea of what's going on. Biggest takeaway lately is the price on these lithium iron phosphate batteries is just plunging. And, you know, it used to be really, they always were a good value. I mean, 100 amp hour battery was nearly $1,000. That's a huge amount of money to put out. But if you look at it for over the life of the battery, it really was cheaper than a sealed lead acid. Well, now we're looking at that same battery being $200. It's a no-brainer. You know, to get 5,000 charge discharge cycles versus maybe 500, and to have a battery, 100 amp hour battery, really is the equivalent of about 180 amp hour sealed lead acid battery, because those can only be drawn down to 50%. You know, really those sealed lead acid batteries are, I don't know that they'll go away, but they certainly are not the value and not recommended anymore.
Yeah, no, I was really amazed as I was dragging all this stuff out of the garage and out into the yard to be able to do all of this filming. And I grabbed that motorcycle battery, which is a lead acid, and I don't actually have it filled with the acid, so it's just a prop piece for me at this point. But the weight of that little small battery, and I think it's like 8 to maybe 9 amp hours of power in that thing, is almost exactly the same physical weight as that 80 amp hour Bioenno battery, that lithium iron phosphate. It is remarkable to see the energy density that's in those as compared to the lead acid, really for the weight. It is absolutely remarkable. Now, something that I didn't mention, one of the batteries that you'll notice that I didn't show are the LiPo batteries. These are the ones you'll find oftentimes in the little pouches that you have, and you want to probably steer clear of those batteries. Those are the ones that are the most sensitive. You'll see the cells on them will kind of swell up. You see these a lot of times in your laptops as well. And these are batteries that oftentimes can spontaneously combust. One of the really nice things about the lithium iron, or the LiFe PO4, lithium iron phosphate, is that iron in the mix of the molecule really adds to stabilize that cell. Now, it's not saying it's perfectly stable, but it is much, much more than the LiPo batteries, the energy density, and really that decay curve. When those lithium batteries, as you're working with them, they will maintain their voltage all the way up until they're just about depleted, and then they drop off pretty much into nothing very quickly. But you end up getting much more power out of them, and as Dan said, the charge cycles is one of the big stories also with these batteries. So
the other thing about the lithium iron phosphate batteries is they start out at about 13.3, 13.4 volts. And for about 90% of their lifespan, or their discharge cycle, they're at about 13 volts or above. So you have a higher voltage output at 90% depletion than your SLA battery has when it's fully charged. And our devices, they say 12 volts, but they're really designed to be optimally powered at around 13.8 volts. So you're giving your radio what it really wants and probably getting a little bit more power out of it, although it's probably pretty small. But to get over 13 volts through the majority of its discharge cycle is really remarkable.
That's pretty great. And for folks, since we have been working with the folks at Bioenno Power, they've been gracious enough to add a discount code for you. So if you fill out WaveTalkers at checkout, it should get you an extra 10% discount off of your order directly through Bioenno. So big thanks to them for helping to support us. Let's go over to Scott. Hey, Scott, what were your thoughts on today, and what were the other things that we missed in this discussion?
Oh, really good stuff. And like Dan said, we can do complete shows on generators and inverters. Probably some of the key takeaways on some of those is pure sine waves, because a lot of your electronics just require that pure sine wave to work effectively and appropriately. I posted a lot of information in the chat. Other big takeaway on generators. Chris, you kind of hit upon it really well. Try to get the fuel out of the carburetor. I run in all my small engines, both at home and at my public safety facility, ethanol-free fuel. And I can get ethanol-free fuel like at Home Depot and Lowe's. It's the ethanol that really jams up these carburetors when they sit for a long period of time. And a good product I posted in the chat is by Starbright. It's called Startron. The fire service, we use all of that stuff in our small motors to preserve the motors, and it comes highly recommended by the manufacturers. It's an enzyme-based fuel additive, unlike Stabil, which it's a chemical additive. Other thing about lithium-ion batteries, guys. So, Chris, you hit upon it with the LiPo battery. Regardless of either battery, lithium, pure lithium, which is in these batteries, is air reactive. So the problem is, if you puncture even a lithium iron phosphate battery, there's still pure lithium in there, and its exposure to air could create a catastrophic failure. And or, as we saw in some videos, salt water will cause these batteries to have catastrophic failures. So just be cognizant of how you treat your batteries. because they can create some problems for us out there.
And they're
But
hard fires to put out.
absolutely hard fires to put out. And the biggest issue with lead acid batteries, as you hit upon, Chris, if you knock them over, you spill out that acid. That's really damaging to tissue, to a lot of things. So you need to be really careful when dealing with lead acid batteries, is not to transport them on their side and things like that. And even the sealed ones, don't puncture them. It creates problems for you. So just some good safety issues when we're talking about batteries. They're great devices. And of course, with gasoline, with generators, keep them separate when running your generator.
You know, there are other battery chemistries out there as well. Certainly from the marine environment, the AGM or absorbed glass mat batteries, and there's a couple of others. The marine deep cycle batteries. I mean, we literally could do entire series of shows on just different battery technologies, power inverters, and so forth. The equipment that we showed today was to get you a good idea as to how the overall flow of all of these things would work together. Maybe not all of them are optimally designed for operating your radio equipment. As you know, we keep mentioning, make sure you got a pure sine wave on your inverter, on your APS. So the pro models of the APSs a lot of times they'll note that they have a pure sine wave generation in them. So those are the things you want to look for. They definitely cost a few extra dollars to be able to get all of that in there. But this should give you a pretty good overview of the different ways to be able to think about emergency power, and you need to be able to adapt to whatever the situation that you're facing happens to be in order to pull all of your particular needs together.
Hey, Chris, one last thing on it. Hey, so a lot of us have been really on the fence about lithium batteries because of the environmental backside to them on what do I do with a battery that after it's gone dead. Hey, believe it or not, I was at an event this weekend and I was hearing conversation that there are some agencies out there who have figured out how to recycle lithium batteries and not make them an environmental issue for us, which is a really big thing because, as we trade technologies, we trade one thing for another thing. And how do we be responsible of the environment at the same time is also important. And Chris, I failed to mention those clamshells that you had on your batteries. Hey guys, you don't have to run alkaline batteries in them. You can actually run lithium AA batteries in them, and you can recharge those batteries so you're not creating more waste by throwing out alkalines out there, and you'll get better life out of the lithium AA's than you would an alkaline AA or a NiCad AA in those clamshells.
Absolutely, yeah. I mean, there's so many more levels we can dive into in these topics. Hopefully, this gives everybody a good overview of what we've been doing. If you really found any of this information super helpful, consider going on to our WaveTalkers site. Use that Buy Us a Coffee link. It helps us fund and keep all of this information coming out on a regular basis. So, with that, if you're here inside of the Zoom, hang around. We're going to open up the mics and do the after party where we'll take your questions. If you ever want to join us for the after party, just go on to wavetalkers.com. At the bottom of every single page, there's a join us link. Fill it out. We send you a link to our live show that you can join us here inside of the Zoom and participate in the after party. And with that, we'll say 7-3 to everybody, and we'll see you again next week. Thanks a lot.